Day 5, part 3, transforming the absolute value function. Let's go back to the parent function. Let's get rid of the number that's multiplying it. Let's just go back to the original parent function, this one, and let's add and subtract numbers to it. So let's say I want to subtract a number inside of the absolute values. Well, let's make a table to find out. To see what happens. Sorry, my tables aren't that pretty. Okay, if I plug in a -2, -2 minus 3 is -5. But because they're both inside the absolute values, that -5 is going to become +5. -1 would be 4, +4. 0, 3. 1 minus 3 is 2. 2 minus 1 is 1. Now if I graph that, it looks something like this. One, two, three, four, 5. Starts here, then here, then here, then here, then here. Something's happening there. It hasn't changed direction yet because I'd actually have to continue the table. If I plugged in a 3. If I plug in a 3, guess what I get? 0. So what happens? That middle point isn't at 0 anymore. That middle point is now at 3. And then what happens after this? Well, it's going to go back up. So when you see a number inside the absolute values, it moves that middle point either left or right. And that's what happens. Now, what if the number's on the outside? Well, again, let's make a table. Make it a little bit bigger this time. -2 becomes +2, plus 3 is 5. -1 makes it 1, plus 3 is 4. 0 is 3. 1 is 4. 2 is 5. Now, I graph this one. 1, 2, 3, 4, 5. There. 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 Take a look. What happened now? Well, when the number you're adding or subtracting is on the outside of the absolute values, instead of moving it left and right, it moves it up, or it could have moved it down. So the placement of where you're adding or subtracting numbers changes the direction that you're moving it in. So one of the words we had for this was vertex. So some people call this the vertex form. We're just going to call this the middle point. These numbers will tell you where that middle point has moved. The number inside tells you it's been moved on the x-axis, which is left and right. The number here, the k, on the outside tells you it's been moved up or down on the y-axis. So let's do a combo. This is the parent function. Let's say your new function has been transformed with these numbers. All right. Now you can make a table, or you can follow this rule. Okay. If the formula they have looks like this, what numbers did they give you for h and for k? Okay, well, h is a 2, and it's not a -2. The negative sign's already in the formula, and k is a 5. So what that means is, for the x-axis, it's going to move 2 spaces, but for the y-axis, it's going to move 5 spaces. So here's how it would look if I graph this, all right? One, 2 for x. 1, 2, 3, 4, 5. That is the new middle point. That is the middle point. And if you don't believe me, let me make a table real quick. I'm gonna make a table over here on this side. Just putting in numbers. And actually I'm gonna start with 0. 0, 1, 2, 3, 4. Just to prove that this works. Okay, check this out. If I plug in a 0 in here, 0 minus 2 is negative 2, but you're taking the absolute value. So that's positive 2 plus 5 is 7. If I plug in a 1, 1 minus 2 is negative 6. Absolute value of, oh wait. Yeah, it's going to be a 6 as the answer. 1 minus 2 is 1, plus 5 is 6. If I put a 2, 2 minus 2 is 0. It's not going to change it. If I plug in a 3, 3 minus 2 is 1. 1 plus 5 is 6. If I plug in a 4, 4 minus 2 is 2. 2 plus 5 is 7. Take a look at those numbers. So at 0, 1, 2, 3, 4, 5, 6, 7. At 6. At 5. At 6. At 7. So now you don't even need to make a table anymore, because if you have the numbers here for h and k, it'll tell you how much has been moved. Now, if we look back at our problems here, if you didn't make a table, if you just look at this, what number is h? 3. How much has it been moved? 3 spaces. That's your new middle point. I should have made my table 1, 2, 3 in the middle, and 4 and 5. That's how my table should have been designed, because that's my middle point. If you look at this one, what's your k? 3. Now, not 3 on the x, because it's not on the inside. This is on the outside. Where was it moved? Up there. So there's no way it's going to get lower than that point. It's going to go up from that point. So this equation, this vertex form equation, is a great way to identify where the middle is of your graph. And being able to graph that middle point makes these problems a lot easier, because it tells you where it's been translated on the x-axis and on the y-axis. So the reason we call this transformations is because transformations is when you've changed the original function, the parent function, to make it look different, but it's still connected to that.